Okay, this is 4.5b of geometry. So we have some corollaries here. A corollary is a theorem that can be proved easily using another theorem. We don't need to know that definition by memory or anything like that, but it's just a good thing to know. So we've got two corollaries here. The corollary to theorem 4.3 means you can use the 4.3 theorem, which is our isosceles triangle theorem. Says that if all the sides of a triangle are congruent, then all of the angles are congruent. And the corollary to 4.4, which is the converse of the isosceles triangle theorem, says if all of the angles are congruent, then all of the sides are congruent. Okay, so finding angle measure. Let's try our got it problem here. It says suppose the triangles in problem 3 are all isosceles triangles where angle ADE, so this angle right there, DEC, and ECB are vertex angles. Okay, so those three are all the vertex angles. If the vertex angles each have a measure of 58, what are the measure of angle A and the measure? So we're looking for A. Let me mark this. We'll use a different color. So we're looking for A, and we're looking for the measure of angle BCD. So this whole guy there. Okay, I'm going to just start drawing these triangles separately, I think. So, well, that's pretty bad. Here's our triangle DAE. If this is isosceles, I know that these base angles are congruent. And that vertex angle was 58. So, I know that 58 plus, and I'll call each of these x, plus x plus x equals 180. So 58 plus 2x equals 180. I subtract 58, and I get 2x is equal to 122. Yep. So I divide by 2, and x is equal to 61. So, that answers one of my questions. The measure of angle A is equal to 61. If I look at so now I'm looking for BCD. So, BCD is made up of two of the angles. I'm going to move up top here for this. So here's C, B, and E. I'll stick my other triangle in. There's D. So I was told this vertex angle is 58 degrees. So here's 58. And I need to figure out what that guy is. Well, that's going to be the same measure that I just got for angle A. Because if you remember, all of the vertex angles have a measure of 58 degrees. So this guy down here would also be 58. So if I call both of these, and those, this is isosceles triangle, so the base angles are congruent, so those would both be x's. If I add it up again, I'm getting exactly the same equation. So I would solve it, and I'd get x is equal to 61. Oops. So this angle right here is 61. So the whole angle that I'm looking for, this angle right here, DCB, so angle DCB is equal to, let me make some space over here, 61 plus 58, which is 119. So, I'll copy that down here as well. But now I found both measures. So, there's your homework.